Welcome, scholars, to Mr. Honeycutt's math class. This video has two subjects. We're going to talk about factoring by grouping, and then we're going to use factoring by grouping to help us factor more complicated trinomials. Let's get started on this factoring by grouping. So again, the basic pattern is we're going to turn these into groups. Oh my gosh, that's the name right there. So what's common? So basically, you're going to break each of these up into just little groups. So then what's common to this right here, you're just going to find the greatest common factor there. So it's 16x squared, and I'm going to pull out an x minus 1. And then minus 25. I'm going to pull out here. And here's what's weird, and I want you to notice this. If we're going to pull a negative out of a positive, because a negative times a negative is a positive, that's going to make an x minus 1. Okay, that's kind of counterintuitive, but if you multiply it back out, the negative 25 times x is going to be a negative 25x, and the negative 25 times the negative 1 is going to make a positive 25. So now, hey, we have this thing that we can factor out all together like we've been doing before. Notice it's kind of similar to that meta pattern stuff. And then that's x minus 1 times 16x squared minus 25. Hey, and now I have another pattern within a pattern. This is an a squared minus b squared. So that's going to be an x minus 1 times 4x minus 5 times 4x plus 5. It's like these are all built on each other. Isn't that great? So let's do another one. This is relatively simple here, but so I'm going to factor an x squared out of both of these, and that's going to be an x plus 1 is left over, because x squared times x is x cubed. Remember, that's the implied 1, and there's also an implied coefficient here. Lots of implied stuff. If you get stuck, you're probably forgetting about implied notation. And then what's common to both these is a negative 10. So now I'm going to have an x plus 1. Notice that this, the negative 10, the negative x, that's still equal to 0. And then I can factor this out. So that's going to be an x squared minus 10 times an x plus 1 equals 0. Now, in this scenario, I'm solving this because it's set equal to 0. So I'm going to use the zero product property and set these both equal to 0. Remember, because anything times 0 is 0. And that's the whole point of wanting to set things equal to 0, because we can use the zero product property. Subtract 1. This one's relatively easy. This one's going to get a little tricky. Okay, so that's an x squared equals 10, square root. But remember, this is going to be a plus or minus square root of 10. So this is going to end up having 3 roots. A plus rad 10, a minus rad 10, and a negative 1. So that's the pattern. Let's look at the meta pattern. This one's kind of tricky, all right? I'm not going to lie. I had to actually think about this one beforehand. What you kind of want to look for on these ones where there's groups of 6 or group of 3, that you're gonna, there's 6 things you're going to divide into 2 groups of 3. Look for what has like common factors. So notice that the 9 and the 36 and the 45 are all factors of 9, and then everything else isn't. So I'm going to rewrite this. So I'm going to get x to the 4th minus 4x cubed minus 5x squared. And then putting these in some sort of order here, I've got a negative 9x squared plus 36x plus 45. And now I'm going to start factoring stuff out. So what do all of these have in common versus what do all of these have in common? So this group right here has some x squareds in common. So I've got an x squared. Factoring other stuff out, so minus 4x minus 5. And then here, these all have a 9 in common. Because it's a negative 9, that means my sign on this one and this one is going to flip when I factor the negative 9 out. Because a negative times a negative is a positive. So that's going to be an x squared minus 4x minus 5. And if you're like, wait, what? How does that work? So it's 36x divided by -9. Well, that's going to be a -4x. And if I have a positive 45 divided by a -9, that's going to be a -5. So it does actually make sense. All right, and then now notice, hey, look, this whole thing can get factored out. Ta-da! So I'm going to have x squared minus 4x minus 5. And then what's left over here? Well, that's going to be an x squared minus 9. Hey, look, these can factor further. Oh, isn't that adorable? All right, so I'm going to have x minus 5 and an x plus 1. I knew that because this was negative, so one of them is going to be negative, one's going to be positive, but this one's going to go to the larger one. And the only factors of 5 are 5 and 1, so that was pretty straightforward. Then this one is, hey, look, it's the difference of two squares. Oh my gosh, I told you it shows up all the frickin' time. So x minus 3, x plus 3. So that's factoring by grouping. Again, it's noticing these larger groups. Some of these, there's only, these ones might be kind of tricky, but try to rearrange it. And again, you're looking for what's divisible, what's common to several of these. Now, factoring trinomials with an a greater than 1. All right, so remember, that's when we have like the full-blown ax squared plus bx plus c, where the a isn't just a 1. So I've learned and taught like various ways. I learned it one way in school, and then I kind of like figured out my own way, which I limped along with. And in fact, even when I was a algebra teacher in California, that's kind of the way I taught my students there. And every once in a while, it is a superior method. But when I was a tutor, I had a student teach me this method, which some people call the master product method. I think Ms. Ulrich taught you guys like a reverse box method. Great. Like there's no real perfect process for this. Like I've just found this to be a good process. All right. So the first thing you're going to do in this process, if you haven't seen this before, if you have, that's fine. You're going to find the a times the c. So in this case, that's like the master product. So that's going to be the 4 times the 3. Okay, in that case, that's going to be 12. And there is some delta math that asks you to figure out the master product first, and then you're going to go from there. And then what you're going to do is you're going to list factors of that a times c, which in this case is 12, until you find a sum that's equal to the actual b, which in this case is 8. So what I'm looking for, and by the way, it's a positive 12, all right, because you make sure you do include the sign on that. So what two numbers multiply to become positive 12, but add to 8? So if I do 3 and 4, 3 plus 4, hey, that's 7, that don't work. Okay, well, what other factors of 12 are there? Well, there's 2 and 6. What happens if I add those? Hey, that's positive 8. Oh my gosh, I have found it. So this is the weirdest step of it. What you're going to do is you're going to split the positive b into these factors. So in this case, that's my positive 8x. I'm going to split it into a positive 2x and a positive 6x. Watch what happens. So I'm going to have a 4x squared plus 2x plus 6x plus 3. In this case equals 0. When I do that, and it actually does not matter which order you do these one. It really doesn't. You can do it either way if you don't believe me. And then you're going to factor by grouping the thing that you've split. So what can I pull out of both these? Hey, I can pull a 2x out. Oh, isn't that wonderful? So that's going to be an x plus 1. And then I can pull out nope, there's a 2x. There it is. Whoops. So 2x plus 1. And then I can pull a 3 out of this. If I pull a 3 out, that's going to give me a 2x plus 1. And then now, hey, look, I've got this big group that I can pull out here. And there's just one of them. So that's going to end up being 2x plus 1 is common to all. And then that's going to be 2x plus 3 equals 0. And then I would solve these. You're going to get x equals negative 1/2 and x equals negative 3/2 once you solve. Probably should have taken a little more steps, but you'd use the zero product property, set them both equal to 0, solve, yada, yada. So, but that's the factor pattern. So the first thing I'm doing is finding that master product, which is the A times the C. Then notice at that point, this step then becomes very similar to what you were doing when the A wasn't 1. Okay? But then this next, in like figuring out what the factors are, like what multiplies to A times C equals and adds to B. But then you do this weird thing where you split it here and here. By the way, you can do this on the factoring trinomials, the regular one, like that. It still works. This just takes longer. And then you're doing this factor by grouping stuff. Yeah. If you've got another method, that's fine. Like I make sure it works. So this is what I found to be helpful to most students. So now let's try one with a meta pattern. Oh Lord, look at this terrible, nasty one. Now, on the Delta Math, if you get one this awful, like yes, you absolutely positively can use a calculator. So yes, and then so my master product in this case is going to be 4 times 3136. And I think that ends up being 12,000. I'm actually reaching for a calculator right now. 4 times 3136. Oh, yeah, 12,544. Now, that's pretty big, in case you can't tell. Now, let's use our sign rules to help us figure some stuff out here. This is positive. My C is positive. That still tells me that they're going to have the same sign. Then that means that this one is negative. So as I'm even setting up my factors, even though I don't know much about it, I know it's going to end up being a negative, negative. I'm probably going to need more room. Now, the other thing that I know, we're going to get real fancy right now, is that this is an even number, which makes this an even number. But then this right here is an odd number. So the only way that I can get, that means I'm multiplying to an even, but it adds up to an odd. That means that the only way I can do that is if one of these factors is odd and one of them is even, because an even plus an odd makes an odd. But if I had two odds and I added them together, that would make an even. And if I had two evens and I added them together, that would make an even. But I have an odd, so that tells me it has to be an even and an odd. So what I'm doing is that's helping me figure stuff out. So what I can then do is then I'm going to start like, okay, let's use some common odds. So I'm going to take that 12, 5, 54, 44, excuse me, and I'm going to divide by 9. And it's going to get me a really ugly answer. All right, I'm just going to show you 5, 4, 4 divided by 9 ends up like 1393 or 3.7. So that didn't work. So what happens if I divide by 7? 1, 2, 5, 4, 4 divided by 7. Notice I'm kind of being systematic. Hey, that worked. That's 17.92. That's interesting. What if this looks kind of suspicious. I'm going to try to divide by 7 again. Hey, and I still also get a correct answer, or a clear answer. So in fact, if I take this 12, 5, 4, 4, I've divided by 7 twice. That's the same thing as dividing by 49. Hey, that's 256. That looks suspicious. Notice that these, if I were to then add them, the 256 and the 49, that's going to be the negative 305. Now, in some ways, I got kind of lucky in recognizing the 7s, but I did have a false start with the 9, but I was starting with odds, okay, because one of these things had to be an odd. So, but that tells me that in making this ultimate pattern here, remember, I'm first going to do the grouping, but I'm going to end up with the negatives here. So I'm going to have that 4x to the 4 minus 49x squared minus 256x squared plus 3136 equals 0. And then I'm going to do this factor by grouping stuff. So looking at it like this, I can pull an x squared out of both of these. And then I'll have a 4x squared minus 49. Okay, minus. Now I'm not going to quite pull all the 256 out because I want to end up, remember, with one that looks like this. All right. So what's 256 divided by 4? Well, that's going to be a 64. And I can check that to make sure that this is actually going to work by pulling, all I do is just 256 divided by 4, and that's 64. And I can check that that's going to make sense with by multiplying negative 64 times a negative 49, and negative 64 times negative 49 is 3136. So that actually does work. Then I'm going to, hey, there's this group and this one. I'm going to pull this out again. So I'm going to have a 4x squared minus 49 times an x squared minus 64. And hey, hopefully we're noticing, again, difference of two squares. So this is going to be a 2x minus 7 times 2x plus 7. And this is going to be 64, that's x minus 8. X plus 8 equals 0. Solving for all this, I'm going to get x equals positive 7 halves, negative 7 halves, positive 8, and negative 8. That's quite a lot of solutions. Same thing with factoring trinomials here. Not same, but similar. What's nice about when you have multiple variables is the middle term will tell you kind of what each part is going to be. So it'll tell you what each of these factors is going to end up looking like. So this is going to be, that means this middle term is h squared, means that these are both going to be h squareds here. Ugly h's. And then the p is going to be to the 6th power. I can also then use my factor patterns here. It's a negative and a negative. So that means that one of these is going to be negative. That's what this means. And then it's the larger one's going to win. I'm going to use my multiple product. So 5 times 32 is going to be 160. What multiplies to 160 but has a difference of 12? So multiplies by 160 has a difference of 12. How about 8 and 20? And hey, I think that does work. So I'm going to make myself some room over here, by the way. So I'm going to have that 5p to the 12th minus, we can do the 20, because it's 8 and 20, yeah, it's the larger, it's got to be the larger. P to the 6 h squared, and then this is what's weird. When you're splitting this one, when you have a negative here, one of them is going to be negative and one of them is going to be positive, which is odd. And then minus 32h to the 4th. And then I'm going to do the same factor by grouping. It's slightly more complicated because I have multiple variables, but it's not that bad. So I've got a 5 of p, it's common. Notice this is pretty similar to the factor, the greatest common factor stuff. I'll have a p to the 6 left over, just like I knew I would from up here. Okay. And then this would be a minus 4. All that's left over is an h squared. Hey, that's what I thought that would be. And then looking over here, all right, what's in common with both of these? Well, I've got an h squared and an h squared, and I've got some 8s. So that's going to be an 8h squared. Then I've got a p to the 6 minus 4h squared. Hey, that's just like this one. And again, then I can factor all this out. So then I'll have a p to the 6 minus 4h squared times 5p to the 6 plus 8h squared. So notice it is obviously a little bit more complicated, but you're doing the same kinds of things, okay? It's the same sort of pattern. So this is really, really, really good practice for your algebra muscles. Think of this as sort of overtraining for what you're going to need to do on the ACT and such. So we have one more. Oh, hey, meta pattern. Yes. Now, so for this one, I'm going to add the 10 cosine to both sides. I'm going to rewrite, so I'll have 8 cosine squared theta plus 10 cosine theta plus 3, and that's going to equal 0. And then again, I'm going to find that master product, which is 8 times 3. That's going to be 24. And then looking at my signs again, what numbers multiply to 24 but add to 10? Well, for 8 and 3 is the first one, but that adds to 11, so that's not going to work. So how about 6 plus a 4? Hey, that does work. That's going to make 10. So breaking this into that factor by grouping, I've got 8 cosine. So plus, let's do 4 cosine theta plus 6 cosine theta plus 3 equals 0. So I just, again, this is probably the trickiest part. I'm taking this 10 cosine theta and I'm breaking it apart into 4 cosine theta plus 6 cosine theta, because 4 plus 6 is 10. And I can do that. That's fine. Do all kinds of beautiful things with algebra. Now I'm going to factor by grouping for these two parts. So what can I pull out of both of these? Hey, I've got cosines in common. I've got a 4 cosine in common. So I'm going to have a 4 cos theta I'm pulling out. There's still a cosine left over because that's a cosine squared. So I'm going to have a cosine theta. And it looks like plus 1 because that's in common. And then I've got, looks like I can pull a 3 out here. So that's 3. And I'll have a, oh, there was a 2 here. Yep, whoops. So that's a 2 cosine theta plus 1. Notice I was able to use the fact, hey, I knew, and since there was something wrong because this was not equal to this, and then I was able to go back and check that to find that error. Equals to 0. And then I'm going to factor these guys out. So that'll be a 2 cosine theta plus 1 times a 4 cosine theta plus 3 equals 0. Now, I can use the zero product property and solve these. So I'm going to have 2 different possibilities. That'll be a cosine theta equals a negative 1/2. And a cosine theta equals negative 3/4. Now this one you ought to be able to do on the unit circle. So negative 1/2, it's going to be quadrant 2, quadrant 3. So that should be, if we're doing this in radians, that's going to be 2 pi over 3 and 4 pi over 3. I'll be embarrassed if that's wrong. And then this one, you would have to use a calculator on that. So let's do an inverse cosine. All right. It's the same quadrants, but of negative 3. And I should make sure that I am in radians, since I just did that one in radians. I think the actual delta math wants you to do this in degrees, but whatever. I'm just going to give this answer in radians. So that's going to be 2.41 radians, which is somewhere in quadrant 2. So to get to quadrant 3, the quadrant 3 version of this angle, it's actually 2 pi minus this amount, which ends up being 3.86. And just to let you know, I didn't remember that right away. I had to had to pause the video and go figure out how to redo that. It didn't take very long, but I just want to say, like, sometimes you're going to forget how to do that. If you know the concept around it, you will have enough, anytime you forget something, you have enough math around it to go refigure it out, like I just did. Now, this is all quarter one review stuff on how to solve this. But what matters and what we're focusing on right now is, again, the meta pattern. Most of the time when scholars first see this kind of stuff, they're like, oh my God, it's so different than we've ever done before. I've never done anything like this. No, it's the same meta pattern. It's factoring trinomials. You've literally done this since Algebra 1. It's the same thing. They're just trying to freak you out by throwing in a cosine. Don't freak out. It's the same pattern. Okay? Don't worry about it. You can do this stuff. All right, so try lots of these factoring trinomials. I gave lots and lots of delta math. This is really good practice for you on this. And then we're going to move on to the actual goal of it today, which is the actual graphing of everything.